take a look at this picture. See, if we want to calculate the mean electrical axis of a heart from the ECG trace, we should take a look at the limb electrocardiographic leads. What are limb leads? Limb lead 1, 2, 3, AVR, AVL, AVF. 1, 2, 3, AVR, AVL, AVF. As you can remember, we have two types of leads on a combination of electrodes. Bipolar electrodes and unipolar. Bipolar electrodes or leads means combination of two limb electrodes. For example, right hand and left hand. This is bipolar limb electrode for lead 1. Right hand and left leg for limb lead 2. Left hand and left leg. These are bipolar limb leads. Which has been invented by Dr. Einthoven in 1901. After that, during 1934 up to 1938, an American physiologist by the name of Dr. Williams thought that if we can connect right hand, left leg, and right leg cables to a high resistance source and make them zero. This is, for example, the combination of these four limbs, which are actually connected to the negative pole, and make them zero. Now we have positive pole at our hand. Positive. Now I can put positive pole on my right hand. This is augmented vector for right hand. This is unipolar limb leads. For right hand, left hand, and left leg. Right leg is electrocardiography is a neutral or ground limb. Right leg in normal electrocardiography is a neutral or ground limb. So we have, if we connect the electrodes of right hand, and left leg, plus right leg, to a high resistance source as the negative pole of the electrocardiograph apparatus and make them zero. Now I want to make an electrical potential between two electrodes. Now negative electrodes are connected to the right hand, left leg, and right leg. Connect to a high resistance source, make it zero. Now we have the positive pole at our hand. If I connect it to the right hand, then that would be AVR. Augmented vector for AV. R stands for augmented. What does augmented mean? Means amplified. Vector means an arrow with a length and direction. Augmented vector for right and for arm. AVL, augmented vector for left and AVF for left. For left. All are unipolar because we use just the positive pole to the right hand, and left leg. These are unipolar limb leads. Now take a look. We have already discussed this in the previous sessions. Now take a look. If I put this positive pole, unipolar electrode, to the fourth intercostal space at the right external border, fourth intercostal space at the right external border, that would be C1 or V1.
Yeah.
The second one, left external border at fourth intercostal space, C2 or V2. Put aside C3, C4, fifth intercostal space at the intersection of mid-clavicular line. This is clavicle, mid-clavicular line intersection at fifth intercostal space. If I put here, that would be C5. In fourth intercostal space, that would be C4. C3 between C2 and C4. Let me repeat it again. Fourth intercostal space at right external border, C1.
No.
Fourth intercostal space at left external border, C2. C3 between C2 and C4. Mid-clavicular line. Let me correct it. Mid-clavicular line intersection at fifth intercostal space at the left side. That would be C4. Now, if we divide the armpit into three lines, anterior, mid, and posterior axillary line. Fifth intercostal space at left axillary line would be C5, mid axillary line would be C6. So we have 6 chest leads in the frontal plane. We have sagittal plane and frontal plane. Sorry, horizontal plane and frontal plane. That would be in frontal plane. In collectively, we have 6 limb leads plus 6 chest leads. This is the 12 standard electrocardiogram leads. 1, 2, 3, AVR, AVL, AVF, and 6 chest leads in frontal plane. 12 standard electrocardiography leads. Now, we want to calculate mean cardiac axis. Mean cardiac axis. Take a look at the picture. In order to measure the cardiac axis, we can use limb leads. See, we have lead 1, lead 2, and lead 3.
Yeah.
We should calculate the positive and negative deflection in each lead. See, we have a zero line. This is the zero line. This is the zero line. This is the zero line. We should measure the positive part and the negative part of the QRS complex in each respective lead. For example, here 3 positive in lead 1, 5 positive in lead 2, see 3 minus 1 equals 2, 2 positive. In each respective lead, you should make a point which is equal to the calculated QRS mean QRS minimum. In limit 1, for example, this is the positive end of limit 1, this is the negative end. The mean QRS here is positive. In limit 2, this is limit 2, for example.
Yeah.
Again, is positive. In limit 3, positive. Now here we have limit 1 and limit 3. Take a look at limit 1. In limit 1 we have this amount positive. In limit 3 between limb lead 1 and limb lead 3. Take a look. From the point we have got in limb lead 1, we should make a perpendicular line. This is a perpendicular line to that point. In limb lead 3, again we have a perpendicular line. This is the projected vector. The projected vector is the mean QRS complex, amount, which is the mean QRS of that part. How much is it? You should measure this angle. This is 59 degrees, and the length is equal to the electrical current. Mean electrical current at that instant. Yes.
But how do we know that this is for limb lead 1 and this is for limb lead 2? How did you calculate that? And also, how do we know the length? You said limb lead 1, its length is 3. How do you know its length is 3?
This is unique. By a ruler. Look a ruler. See? Do we have a ruler here? Or something to measure something? With a ruler. For example, with your hand. See? For each millimeter, for example, or 1 centimeter, how much is it? For example, 3 centimeters. 3 centimeters. 5 centimeters. 5 centimeters. See, here, in this example, the author uses, this is actually taken from the guidance book. If you have brought the respective page, you can see this one. See, from limit 1 and limit 3. In limit 1, you have this amount. In the positive end of limit 1. In limit 3, the negative end is subtracted from the positive one. See, here you have this amount. Okay, using a ruler.
But in the clinic, do we also use
the same? You see, in the clinic, the ECG paper we will see. The ECG paper is a scaled paper, which is divided into 5 smaller squares. This is the ECG paper. This is the scaled paper. Each square equals to 1 millimeter by 1 millimeter. You can measure it. For example, here in that example, 10 millimeter. For limit 1, 10 minus 2 equals 8 millimeter. Then using a ruler, 10 millimeter, 8 millimeter. Make a projected vector. Then the angulation of that projected vector equals to the cardiac axis, and the length equals to the electrical potential.
Okay, how do we know that for you see in the example they said this is the QRS for limb lead 1 and this is for limb lead 2. So how did we know that? Is that by measuring the QRS for each limb lead differently?
Exactly, yes. You can calculate or draw the electrical axis, the mean electrical axis in this example using limb lead 1 and 2. Here in this example, it uses from limb lead 1 and 3. You can use 1 and 2 or 2 and 3. That will be possible. That will also be possible. We will have these practices in the practical class. I will learn you how to measure it in the practical class. This is one example that is actually brought in Guide Physiology. Give me the book. See? Bring that. I've taken it from the book. Okay, look. This is it. Take a look. This is the same.
Yeah.
How to measure the electrical axis?
Is it always from the QRS wave?
Yes. Now take a look at the next example. that is brought in the book. For example, suppose that
that example which you asked me about in the last week. I can't remember.
see, suppose that we have pulmonary valve stenosis, or pulmonary artery hypertension. Pulmonary artery hypertension or pulmonary valve stenosis, or tetralogy of Fallot I have discussed. In all these cases, the blood cannot move freely from the right ventricle to the pulmonary artery. Then the right ventricle will be hypertrophied. You have large mass, large myocardial mass in the right atrium. So if you have a large muscular mass in the right ventricle, when depolarization starts in both ventricles, which part should be depolarized first? Right part or left? Left. Because in comparison to the hypertrophied ventricle, here in this case is the right ventricle. Left part should be depolarized first. Where somewhere in the heart is depolarized, what electrical signs does it have?
What do you mean by electrical signs?
Depolarization means what?
Means membrane voltage is increasing, as becoming more than.
No, ionically tell me what is happening during depolarization.
The ions are being switched and more.
Which ion?
Sodium.
Sodium ions. Sodium ions comes into the cell. Means the cell starts to be depolarized to be negative at the outer part. Means when the right ventricle, this is the right ventricle, this is the left ventricle. Normally the left ventricle has more muscle than the right. Here in pulmonary stenosis, pulmonary valve stenosis, the right will be bigger than the left. So which part is depolarized first?
The left.
The left. Means the left would be negative earlier than the right. So as we can remember, I'm sure you didn't have learned this part. So when somewhere, based on what we have learned in the previous session, when depolarization reaches to the positive pole of an electrode or lead, you will have a positive deflection. Now, left ventricle depolarizes first, means becomes negative in the left side. And the arrow will be switched to the positive part. Which one is positive now? Here is the right. So you will have an axis deviation to the right, as you can see here. Take a look.
So what we can understand from that?
What you can understand, take a look. Here you have limited 1. Give me a net charge in limited 1. See, it's negative. This is negative. How much? See, negative 1. This is the QRS complex.
-1?
5? Is it like 5?
No. See,
No, it's going
this is negative. Take a look. This is limit 1. Take a look at limit 3. How much is it positive?
It's much more positive.
Much more positive. Take a look. Now here in this example, let me see what is happening. Limit 1 is negative. Limit 3. Take a look. This is limit 3 and limit 1. This is the amount of QRS net deflection in limit 3. This is in limit 1. From limit 1 at the apex of this arrow, make a perpendicular line. This is a perpendicular line from limit 1. From the apex of this arrow, make a perpendicular line. At the intersection, you can connect it to the center. Then this angle equals to the mean
Axis.
mean axis.
So, when it's going down,
Pardon?
when this way,
Now, what's your question?
in the next one,
In electrical axis, we are discussed. Now we are here.
next.
Right axis deviation. See,
Yeah, so I'm
in
saying,
limit 1, you have this amount. It is totally negative. See, this is in limit 3, positive. Now make a projection. From here, make a perpendicular line. From here, make a perpendicular line. This is the projection vector. And the angle is equal to, it is mentioned somewhere here.
What about number 3?
Number 3?
Yeah. It's like,
Let me show you on the board. Maybe something you cannot understand from here. Let me show you. Where is the eraser? That model.
It's,
second.
Okay. Thank you very much. Thank you. Now let us show you something very interesting. Take a look. This is limit 1, am I right? And this is limit 2. Am I right? Huh?
Yes.
This is the coordinates. This is the positive end of limit 1, this is the negative end. Am I right?
yeah.
Am I right?
Right.
This is limit 3. This is the negative end, this is the positive end. Now I want to make a net voltage. See, this is the isoelectric line. How much is it? 1 unit. Positive. 1, 2, 3, 4, 5, 6, 7, 8. How much is it?
7.
Minus 7. From here, this is the 0 line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 minus 1 equals to positive 13. In limit 3. In limit 1, we have minus 7. This is the positive and negative end. 1, 2, 3, 4, 5, 6, 7. This is a point. Make a perpendicular line to that respective lead axis. This is perpendicular line. Am I right?
Yeah.
Okay. Now, in limit 3, positive 13. This is the negative and this is the positive end. See? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Make a perpendicular line from this point. See? There is where these two axes actually cut each other, intersect. From here to the center. That will be the projected vector, as you see here. The normal cardiac axis is between -30 to 110 or 120. So, is it bigger than 110 or not? I mean this angle.
No, it's less.
This is limit 3. Limit 3 is 120. So it is more than 120. So what do we call it? Up to 110 is normal. Come in. Very good morning. The normal cardiac axis is between -30 up to 110. It is more than 110. What do you call it?
Right axis.
Right axis deviation.
59 is normal. Normal?
No, it is abnormal.
Abnormal.
It is abnormal. Why do we have right axis deviation in this case? Because you have pulmonary artery valve stenosis.
Is that
Pulmonary hypertension.
Yeah, is that pulmonary hypertension, like we can call it, like, or we are talking about the brain bridge?
From
Brain bridge?
Bainbridge is something else. Bainbridge is a reflex.
Yeah, it's also happening when we have
First defines Bainbridge reflex. Define what is
reflex. It's a reflex.
What is
yeah.
it?
It's a neural reflex to something happen in the circulatory system when we have a high blood volume in the right atrium.
So what?
So,
the right atrium. So
yeah.
what happens?
So that reflex.
Bainbridge is a normal. It's in normal situation.
Yeah, a normal situation. For example, when we
So when the venous return to the right side is increased, then the SA node is a smooth muscle. It stretches. When it stretches, then you will have higher heartbeat. This is called Bainbridge reflex. So this is not what we are talking about.
So that was normal. Right now we are talking about the
abnormal situation. See, this is your right ventricle. What is the outlet of the right ventricle?
output.
Outlet. So you have a cavity. There is an exit for the right ventricle cavity. What is the exit?
Right ventricle. Right ventricle. The blood gonna come from the
you have
right
a cavity.
atrium.
What is the exit for the right ventricle?
Right ventricle. Pulmonary valve.
Pulmonary artery.
Yeah, pulmonary
At the
artery.
entrance of the pulmonary artery, you have pulmonary valve. So if the valve is stenotic, just like that, if the valve is stenotic, then it cannot pump freely blood from this stenotic valve, and it will use high amount of energy to move the blood from this stenotic valve. So it will be hypertrophied. So if it is hypertrophied, then you will have right axis deviation.
This how much abnormal cases we have for heart?
For heart,
Yeah, for
quite a
example,
few abnormal.
right axis deviation, left axis deviation.
Quite a- This is electrocardiographic wise abnormality. We have mechanical abnormality.
No, I mean the
Electrical
graphical. The graphical. Right now, how much abnormal?
We will discuss it. The first thing you have already discussed is right axis deviation. What is the reason for the right axis deviation? Pulmonary stenosis. First, pulmonary hypertension. For example, the valve is normal, but you have a high capillary resistance in the lung.
So it's
You smoke a lot. Then you will have the pulmonary circulatory resistance. So what is the net effect of pulmonary For example, capillary resistance, right ventricle, right ventricle. The pressure inside the right ventricle will be increased. How much the normal pressure in the right ventricle?
Right ventricle?
No.
It's like between 20 up to 31.
The maximum is 25 on a systolic right ventricle
25.
pressure. The minimum 8. 25 over 8. Am I right?
Yeah.
How much is the left side? 120 over 80. In the left side, the left ventricle or in the aorta? 120 over 80. In the right pulmonary artery, 25 over 8. Over 8. So, in pulmonary hypertension, the systolic blood pressure in the right side can be increased up to 80 based on what in the diagram group is mentioned.
So it's not valve issue.
That would also be the valve issue. If the valve is also stenotic, see, for example, suppose that the total area of the right pulmonary valve, for example, 2.5 cubic centimeter, a square meter. So if it is smaller, then that would be, for example, 125 a square meter. So what would be the result if the area of the valve is decreased? The pressure inside right ventricle will also be increased. The valve is smaller, and it should pump the blood from the smaller valve. Then that will be pulmonary hypertension. Or suppose that between the right ventricle and left ventricle we do not have any connection. Do we have? Between right ventricle and left ventricle? No. There is interventricular septum. So if the interventricular septum is open, is defective, which is called, what do we call it?
I know. I forgot.
You didn't take a look at the book at all.
No.
Did you?
Yes,
No.
I did.
What is the defect, interventricular defect?
I forget.
Between right and left ventricle. Give me the book. Give me the book. I will show you.
Doctor.
You didn't even take a look.
Doctor, excuse me. Can I do something?
Medical. Medical is not right. Hypertrophy of one ventricle. No, hypertrophy of the right ventricle. Take a look. God. Read it. The last line.
Last line. Tetralogy of fallout and intraventricular septal defect. So it's tetralogy of fallout.
Fallow. This is a French word.
Yeah.
In French,
In English,
if there is no vowel at the end, you cannot read that T. Take a look. Let me learn you some French. In French. Read it. Fille. Fille means daughter. Fille means daughter.
you have a good knowledge with the language.
Fallow.
Fallow.
Tetralogy of fallow.
Tetralogy
Ready?
of fallout. So it's an intraventricular septal defect.
Ready?
We cannot see.
Okay. Ready? Chevrolet. Chevrolet is a French. The T is nuclear. Chevrolet. But if I put a vowel at the end, now read it.
Chevrolet.
Chevrolet.
This is also a car's brand name.
Yes.
What? A brand car name, yes, Chevrolet. In Iran, we call it Chevrolet.
Chevrolet.
Chevrolet. But the true pronunciation is called Chevrolet. Hmm? Now, the another one.
Peugeot.
Peugeot.
How do French say?
Peugeot the same. Now here, this is tetralogy of
Follow.
Follow.
Tetralogy
In
of
the Persian translation book, it is wrongly mentioned tetralogy of Falot, which is on the again a great French physiology. Read it.
Claude Bernard.
Claude Bernard.
See, in French, this is O. This is E. This is called Claude Bernard.
Bernard.
In most of the Persian translated book, they call it Claude Bernard. This is Claude Bernard Bernard. Bernard.
You excite me to learn French.
Pardon?
You excite me to learn French.
Yes. I'm reading French. I learned English, I also learned Farsi. Now I'm reading a little Arabic and French.
Oh, you are gonna
Okay.
learn Arabic?
Yes?
You are gonna learn Arabic?
Yes. I really love reading Arabic.
That's really good.
Mostly Alif Layla Layla. There is a
Alif
book
Layla
also-
Layla.
We have also an Arabic edition.
Do you like it? Do you like the Arabic? Did you like the Arabic?
I really love it, yes. Then I was very young. Most of the Persian literature is actually taken from Arabic. After that big attack from the Arab side to Iran, most of the communication has been written in Arabic till the fourth or fifth. After Hijrat calendar, a great Persian poet by the name of Ferdowsi, you may heard his name. The communication is again back to Persian literature. Sadi, which is one of the great Iranian poets, is a student of Mutanabbi.
Yes, المتنبي.
Is the student of Mutanabbi.
والبحر غص فيه إذا كان ساكنا.
Now, you translate this verse. كَسَنُّورَ مَغْلُوبًا يَسُولُ عَلَى الْكَلْبِ. What does it mean?
I couldn't understand.
Like he didn't understand how it was.
How
You
it?
don't understand?
He didn't.
Can you
What does
repeat?
Senur in Arabic? Means means cat. Senur.
Yeah, السنور. السنور. Yes.
كَسَنُّونَ مَغْلُوبًا
كالسنور مغلوب
يَسُولُ عَلَى الْكَلْبِ.
يسول على الكلب.
Means attack the dog.
Yeah.
Am I right?
It's Sanur is a type of the cat,
What
so
type of the cat is it?
it's a wild cat.
A wild cat.
Yeah, a wild cat. It's not like normal cat that we know.
Or I have learned quite a few Persian Arabic actually. It's like Salil Masana, Rakiban Tahim fil Falawati. What does it mean?
سل المصانع ركبا تهيم تهيم في الفلاوات. I don't know what he mean by
Sal
مصانع.
means ask.
Ask.
Masana means
Factories.
Factories.
It means the place where something is coming out of. I think he's talking about the origin of something.
Masana means ponds.
Means
Ponds.
ponds.
It's a water place. Pond.
We studied high school in Arabic and we don't know this.
Ponds.
Leave that. We are Arabic. We are Arabs and we don't know this.
Ask the ponds. Falawat means. Falawat. You are Arabic?
الفلوات is something when
I'm more Arabic than you.
yeah you know الفلوات is something to last in something.
No. What does falawat mean? Falawat means sahra. Means without somewhere without water. This is the Jamal Mukassar for falat. What does falat mean? Oasis. What does oasis mean?
It's a mirror.
Oasis.
Oasis.
Waha.
Waha. What does Waha mean?
Waha is it's a small lake.
No, define it.
It's a place in the desert where there's the water and
There is water. This is the
life.
opposite form for Sahara.
A small
What does
lake.
Sahara mean?
Desert.
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 Yeah.
The Falawat means the Mukassar. Jam Mukassar for Falat. Falat means somewhere without any water. Am I right? Without any water.
We assume we don't know.
You don't know? Really?
You know, it's sometimes the Arabic it's become hard even to us because it was my most hardest subject in
When you
the
were
middle
talking-
school.
When you were talking in front of the, I've actually listened to what are you talking about. You see?
Really?
Yes. I really know Arabic. I really know language. Sal al-masana al-tahimu fil falawati. Tahimu means rocket. Means ask those horse riders who are galloping in Sahara, somewhere without any water. The next verse is in Farsi. تو قدر آب چه دانی که در کنار فراتی؟ Farad, where is Farad?
It's in Iraq.
That big river, yes, I've seen it. Means you don't know how somebody feels who is near Farad. Means where somewhere leaves filled with water.